This is a demonstration for problem A3 for chapter 2. We finished problem A2 and A1, and these are here all ready for submission. And I've added a page A3 and pasted the problem into a box. The problem invites us to, it says this, a testing company developed an English grammar test that had a maximum possible score of 20. The company asked 5 high school English teachers to take the test, and they achieved scores of 17, 19, 14, 20, and 20. Compute the mean, median, sum of scores, variance, and standard deviation. Examine the results, and then explain what they mean to someone who doesn't know much about statistics. And I want you to pay attention to this explanation part in particular, because you'll see what I'm looking for in the explanation once you see what the problem is. So we'll begin today. There are only 5 scores in the data set, so I'll be just copying these in today. So let me start out, as always, by giving our participants names. Teacher 1, Teacher 2, and doing so always helps us to keep in touch with what it is we're actually working on, what the numbers are representing. So the scores are always indicated by the letter X. Teacher 1 had 17, and we had a 19, a 14, a 20, and a 20. For more scores than this, I never write them by hand because I'll undoubtedly make a mistake. So I am going to put down the information we'll be needing right here. This is where I'll create my answers. And on the right, I'll be writing out the formulas as we go forward. So we begin by, I always start with N, which is the number in the sample, because we always need to have that as part of our figuring. It's just a habit that I do. Then I'll put an M for where I'm going to write mean. I'm going to put an SS for sum of squares. I will put a VAR for variance and SD for standard deviation. And we are also asked, are we asked to put median? We are asked to put median. So I'll write median as my last. And this is where my answers will be. So the very first thing we need to do is we know we need to have N, which is the number in sample. And in this case, it is 5. And then we need to calculate the mean, which is the sum of all the scores indicated by X divided by N. So let's go ahead and put those 2 numbers in. The number I can see we have 5 teachers. And the mean, let's calculate, equals the sum of all of these scores, 1, 2, 3, 4, 5. Whoops. If you look up here, you can see equals, and then I wrote sum, and then in parentheses, C8 through C12. I'm going to put the closing parenthesis and divide by that 5, or N. I'll just write 5 in here. So now you can see our formula. This corresponds with the cells I use. Your cells might not be the same, and I'll hit enter to find out that the mean is 18. Next, I need to figure out the deviations. And the deviations are equal to X minus M. So I'm going to make a deviation column. And I'll write X minus M. So remember what this is. And let's go ahead and calculate these. Equals, here's the X minus, and let's click in the mean cell, 18. And what I want to be careful of is I have to just indicate to Excel that I want it to stay right there in row 9 and not to move down as it usually would do by default. And so I need to do so by putting that $ before the row. And that should be the deviation. Let's see if it looks right. 17 minus 18. There it's showing us what it subtracted in blue, C8, 17, minus in red, 18. And we did get very sensibly 18 minus 17 minus 18 is in fact -1. So we can take this formula. I can hit Control C to copy it. I can select the 4 after the initial cell and hit Control V to paste in my formula. And so now we have the deviations. Our next step is to make our squared deviations, which is x minus m squared. And I'm just going to put the squared here. Either way that you want to indicate it is fine, but we already have the x minus m, so we'll just square it here. Very simple formula. We'll type our equal sign. We'll type in the value we want to square, type in that up caret and a 2 to indicate a squared. And -1 times -1 is 1, so I'll copy that. Let's run it down the data, and there we have our proper data. So now we have our squared deviations. Let's write that up here. These are our squared deviations, x minus m squared. And so now we know what that column is. And so let's sum those up to get our sum of squared deviations. So our sum of squared deviations is the sum of all those deviations, x minus m, squared. So we have our column here that will be summing our squared deviations. And let's go ahead and calculate the sum. Equals sum of our squared deviations. For our variance, that's that odd figure that we use in the midway through in many calculations. And we simply take our sum of squares and divide by n. Remember, later on, we'll be calculating our variance a little bit differently, and you might see it online a little different if you're looking these formulas up. Here, for these data, we calculate it this way, and you'll learn why we do that later. So our variance equals sum of squares divided by, and our n is 5, so I'll just write it in this time. And we have a variance of 5.2. Our standard deviation equals the square root of the variance. And so let's go ahead and take the square root, SQRT, of the variance. Enter it, and we find that our standard deviation is 2.280351. Our median is the number in the middle, and if we arrange these in sequence, which I will do by selecting these 4 and sorting them, I'll go to Data, I'll click on Sort, and I'll tell it what column to sort by, the column that has a header of X, our scores. And now we see that the scores range from 14 to 20, and the one right in the middle is 19. Our median is 19. So now the part of this that's a little challenging is going to be to write out what this means. And so I'm going to insert a little text box here, if I can. See if it'll allow me to do so today. And for some reason, I don't know why, that's blacked out. I'll try it one more time, and if there it is. Not sure what was going on there. And I'm going to just make it the right size to fit the space. So how I'm going to explain this? Well, this is where we want to go back and think about what these data mean. So the first thing that I can observe about the distribution is that it's likely going to be skewed, because I can see that the mean 18 is lower than the median. So we have a kind of a negative skew. So let's investigate this. Now, this is a test of English grammar. And I would think that English teachers would do really well on an English grammar test. I would hope so. And it looks like a number of them did. 20, 20, 19, they all did really well on that test. And then we have even a 17 isn't too bad, but then we have one who has a 14. And so I would say that a few things here. So we're asked to explain this to a person who doesn't know much about statistics. So I'm going to describe this test a little bit. I'm going to talk about this. This is an English grammar test. And one might expect English teachers to perform well on such a test. 2 of the teachers in our sample achieved scores of 20, and 1 achieved a score of 19. We may have what is called a ceiling effect in our data set. If one speculates, as might be reasonable, that 20 is a perfect score on the test. This would mean that the test lacked the capacity to measure really advanced grammar skills, because it maxed out at 20. We can also see that one teacher performed rather poorly with a score of 14. This may be concerning to the school stakeholders, as it would be desirable for English teachers to have strong grammar skills. If in fact a ceiling effect is present, then it explains in part the negative skew indicated by the difference between median and mean. In other words, that low score of 14 was an outlier and pulled the mean toward it. So we might be saying things like this, but what I want to see in your answers is some reflection that you thought about what the data meant in the terms of real life. And that's what I'll be looking for in set B when you're asked to explain things like this. So you'll notice that I did use the terminology of the course, like skew and outlier, but I tried to explain those terms when I use them so that a sixth grader could understand. That's typically what we do, or so that a person who doesn't know much about statistics could understand it. So hopefully this was a helpful explanation, and we'll end this demonstration.